those terms in, just make sure you get all of them in there. All right, what do we get?
Negative 2 times a squared plus 2ab.
So negative 2a squared.
Oh, you mean total?
Yeah, let's get rid of all the parentheses.
It's
So
negative
minus 4ab
ab minus
minus
2
2b squared
plus 4a.
4a
Plus
plus
4b
4b
minus 3.
Remember, whatever's inside the parentheses is what you substitute in for x. A very common mistake is to put it in for the first x and forget to put it in for the second x. So make sure you put that quantity in wherever you see x. We're going to need that again in a few minutes. The next step is to talk about domains. So remember, the domain set is that first set, the set where the x values come from. At this point in the course, we are not going to talk a whole lot about the range. That will come up a little bit later on. Right now, we want to concentrate on domain. What we usually say is the domain is the biggest set of numbers that will work in the function. Well, we need to talk about what does work mean. So we can look at three kinds of functions at this point in the course. First category is polynomial functions. I'll put several of these on the board. Let's do f of x is negative 2x plus 3. G of x is 5x squared minus 9x plus 2. H of x is 1/3 x to the 4th plus 9/2 x cubed minus 17x squared plus 21x minus 4. So remember, in polynomial functions, it basically means, we can think of it this way, you can have numbers in the denominator of a fraction, but you can't have variables in the denominator. Now, in all of these functions, I can plug in anything I want to for x. It might not be easy to figure out. If I ask you to find h of 93, it can be done. It would take us a real long time, but it can be done. So the domain for polynomial functions is all real numbers. We can plug in anything at all for x and it will work. It might not be easy to do, but it will work. Second category, rational or fractional functions. So once again, I'll put several of these on the board. Let's look at f of x is 1 over x. G of x is 1 over 2x minus 3. H of x is 5x plus 7 over 9 minus 4x. Let's do capital F of x is x plus 5 over x squared minus 5x plus 6. So these are fractional functions. This goes back to something we talked about a little while ago. Remember, I said division by 0. 0 in the bottom of a fraction is undefined. So the domain for a rational function is all real numbers that will work. So anything that won't give you 0 in the denominator. So for this first one, the only restriction we have is x cannot equal 0. Why can't we use 0? It will give us 0 in the denominator. All right, function g, what can't we use?
3 halves.
3 halves? Why can't we use 3 halves?
You're 0.
Make the denominator 0. Now, nobody said you have to do this in your head. You can write down what makes 2x minus 3 equal to 0. You don't have to do it in your head, you can write it out. What's the domain of function h? So x cannot equal
9/4.
9/4. Once again, you don't have to do it in your head. You can write it out. Big F of x. What's the domain?
3 and 2.
X cannot equal 3 or 2. How do we get 3 and 2?
Just back a bit.
Oh, we factored that. Set each factor equal to 0, so we can't use 3 or 2. Now, one quick comment here. I have not looked at how they write the answers for these in the back and forth. I know that there are some textbooks that absolutely insist that you write the domain in interval notation. So it will say the domain for that first function is the interval from -infinity to 0 or 0 to infinity. For a function big F, it will say the domain is -infinity to 2 or 2 to 3 or 3 to infinity.